We've got a couple of magnets, a bar of mild steel, and a furnace, and we want to see what happens if we start combining these together. The magnets, of course, right now are attracted to the bar of steel, but we want to see what happens if we start heating these things up. If we get our steel glowing orange hot, will it still be attracted to the magnets? If we get our magnets glowing orange hot, will they still be attracted to the steel? And after we do all of those things, we might just try melting some of these down, the steel and the magnets, until they're completely liquid, and see how that affects the magnetism. Here's the basic idea. We'll try heating up a piece of steel and seeing how long it retains its magnetic properties. We'll then try heating up the magnets themselves and see how well they retain their magnetic properties. Finally, we'll try melting down both and seeing how they interact with each other. First up, we're going to fire up our furnace, put our bar of steel down inside so one end of it gets super glowing hot. And we're going to pull that out and see if it is still attracted to either of our magnets. One end of our steel bar is now glowing orange hot, and this furnace gets up to about 2,000 degrees. So let's see how magnetic a 2,000 degree bar of mild steel is. So in theory, at about 1,400 degrees, it stops being magnetic. Pretty much nothing on the ceramic magnet. Our steel was glowing orange hot, and at that point it was no longer attracted to either of our magnets. The ceramic magnet isn't all that strong, so it shouldn't take that much loss of magnetism for it to not stick to that. But the silvery neodymium magnet is very powerful. That thing has a lot of pull strength, and that had no attraction to the steel. At approximately 1,420 degrees Fahrenheit, mild carbon steel is supposed to lose all of its magnetism, and this bar was well above that temperature, so it doesn't really surprise me that it got to the point where it wasn't attracted to the magnets. In theory, the steel also has to cool down to about 500 degrees before it regains that attraction to magnetism after it's been heated up that high. So now I want to try the reverse. I want to see what happens if we heat our magnets up to see if they stop being attracted to the steel. Oh, and it's shattering immediately. Well, that didn't last long. That just exploded into pieces. So now we know that ceramic or ferrite magnets really don't like to be heated up. That's just gone. I gotta say that I know these are pieces, and so they're not gonna have as much directional magnetic charge, but even just being in there for that long, this isn't really sticking to the tongs much at all. But our ferrite magnet has now had time to cool down, and it is now doing a better job of sticking to our tongs. Not every piece. That piece in particular seems quite weak. Furnace has had just a minute to cool off, so now I can just reignite this and let that get nice and hot. Now these magnets are mostly made of neodymium. Neodymium is atomic element number 60, and these magnets, while largely made of neodymium, also contain some other metals. Neodymium on its own has a melting point of 1,861 degrees Fahrenheit, which is below the temperature that our furnace gets to. So it's possible that our whole magnet could just melt in here. The magnets, however, are an alloy, and it could be that whatever other metals are mixed in with it raises the melting point, so our magnet will be fine. That is one glowing hot magnet. Let's see if it's attracted to our steel bar. Nothing. Zero attempts to grab onto that bar. It's not rolling with it, it's not sticking to it, just really zero. Let's take this out and set it on our brick. Not sticking to our tongs at all either. Let's see if it starts sticking as it cools down the same way that the steel bar started sticking as it cooled down. While it's cooling down, there's something else I want to try. Got these two identical square magnets with a couple of holes in them. We're going to put one in the furnace, heat it up till it's red hot, take it out, and then place the other magnet right on top of it and see if it makes any difference in how much magnetism this gains back as it cools down. One of the square magnets is heating up in the furnace. We've got our other square magnet, and I want to see if it's attracted to this first magnet we heated up. At this point, the first neodymium magnet we put in there is still not being attracted to the metal at all. So I'm curious if our fixed magnet here will be attracted to that material even though it's not attracted to steel. That is a yes. So the bigger magnet that we put in first, the cylinder, is not attracted to the metal itself, but another magnet is attracted to the cylinder magnet. That makes me think we have eliminated all of the magnetism out of this magnet, and it may or may not come back. Let's pull our square magnet out of the furnace and let it cool down in the presence of this magnet. Not attracted to the tongs at all. Okay, currently not attracted much. Maybe a tiny, tiny charge. Let's let those cool down completely. Our magnets have now had long enough to cool down, and we have nothing. There is a very slight draw. It is really little, but you just barely feel it. It's not enough to lift the magnet. It's just barely enough to feel a tiny tug of resistance. All right, well, let's see about our magnets cooled down together. A little bit to that. Steel, almost nothing. Ooh, this magnet got ruined. So we have really depleted these magnets of their charge. But a non-depleted magnet is still very attracted to both of these. We've got our miniature arc furnace, which gets well hot enough to melt pieces of steel and almost certainly these magnets as well. First, we're going to melt down a piece of mild steel and see if there's any magnetic attraction to it. I kind of doubt it since it does seem to lose its magnetic attraction once it's glowing orange, but we'll see what happens. We'll give it a try, and we'll even let it cool down somewhat in the presence of a magnet and see if that can magnetize the steel itself. Steel has a tendency to spark quite a bit when it's melted and this hot, so I am going to be doing this with the lid on the furnace. To do our testing, we're going to have a magnet stuck on the end of our steel bar. Once it's melted down, we'll carefully remove the lid and see what happens if we bring the magnet into the melted steel. I would say that is not attracted to it at all. Big surprise. Not really big surprise. Woo! That was exciting. All right, that is starting to cool down, and I'm just leaving this magnet near it. It could be that the heat from the molten steel is just gonna ruin the magnet. Uh-oh. Oh, I think the heat is winning. My magnet just slid right off of my steel bar. I think my magnet has lost its magnetic charge. And our steel has just really solidly attached itself to our fire brick here. That is a new, still powerfully magnetic magnet. We're going to take our chunk of steel, let it cool down in the water right next to that magnet. Chunk of steel cooled down next to a magnet. It already ruined the magnetism of the first magnet, cooled down even further in the presence of a second magnet. Has it gained any magnetic properties of its own? I'm going to say not so much. Well, let's move on. Let's see what happens if we just melt down a magnet. Well, that is a super bright magnet. Holy cow. That is giving off a lot of light. Like a lot. Huh. The inside is molten. I'm not even that screwdriver. Oh, geez. I think it was about 1400 degrees Fahrenheit. And this was definitely getting hot enough to melt the steel, which melts at about 2500 degrees Fahrenheit, but the magnets were not melting as easily as the steel. So something about the alloy of the composition clearly melts at a fairly high temperature. As a final test, I want to see what happens if I try and melt down this ceramic magnet. There is some melted ferrite magnet, cooled down fairly quickly. It doesn't like to stay liquid, and it's kind of hard to direct the arc right at it because as it heats up, like it did in the other furnace, it just kind of shatters and goes everywhere. So it doesn't like to stay in one place to be heated up nicely, but it does melt. And like all the other magnets we've tested, as it melts, it really loses all of its magnetic power, no longer attracted to steel. Melting metal in magnets really does seem to ruin the magnetism that they have in them. The magnets stop being magnetic when you heat them up too much, and they don't get it back after they cool down. Heating up steel while it's over that mark of about 1400 degrees Fahrenheit, it does lose all of its magnetic charge, but when the steel cools down, it does become magnetic again. Melting steel down into a little blob. I was hoping that we would be able to put a magnetic field around the steel, but in putting the magnet close to the liquid steel, the magnet actually heated up so much that it lost all of its magnetic charge and it's no longer attracted to that piece of steel or any other metal. It's just not a magnet anymore. It's just a block of was magnet. I don't know what to call that. Maybe someday in the future we'll try melting down steel again and letting it cool down in the presence of a powerful electromagnet which shouldn't have its field ruined by the heat.